Okay, so here was the problem where this came up. We got a surprise where one of those triangles came up. So we have a large circle of radius 2. 3 mutually tangent circles inside. It turns out this one has radius 1 and thus passes through the center of the circle of radius 2. And the challenge was to find the radius of these two smaller circles, which are told
they're congruent.
They're congruent. Okay. So this was a problem on your homework. It's a challenging problem. Do you want to try to walk through the geometric ideas on the solution, and we won't solve the
problem.
The problem. Just let's talk about the ideas that are required to solve this problem.
It has to do with two right triangles. I think these are the two right triangles.
Okay. Actually, I like your drawing because well, can you use big dot theory to move the tangent line here? Tangent point here. So I didn't draw it perfectly. This problem is a little hard to draw. So we have this big triangle and we have this big triangle, but they're composed of smaller triangles.
All right.
Okay. And why do we know that we have sort of symmetric properties in this?
Because
problem?
these two circles are congruent.
Okay.
Yeah.
Flip.
All right. Okay, good. So what do we do? What do we do once we recognize? At least we've got some right triangles in here. Well, actually, before I say what we do, what are some of the important geometric ideas that come into play to even recognize these triangles?
Well, you have to look at, it's a bunch of circle properties.
Okay.
So this line here is a tangent line to both of these.
All right.
And that these are both right angles.
Okay. And if we've got two right angles here, can you tell me what does it mean about the line segments? One that goes from here to here, and the other one that goes from here to here.
It's straight.
Why?
Well, 90 plus 90 is 180.
Okay. And what's special about 180?
It's just a straight line.
That's a straight line. Okay, good. All right. So since we have a tangent line here, we can get two right angles.
And then we know we can call this length, this is R.
All right. And that's what we're looking for.
Yeah. And then we know that this length here is 1, 1.
Okay.
Yeah.
No, this is R.
Okay. Let's talk about that line that you're saying is a straight line with length 1 plus R. What's going on there?
Well, you have the two radii that meet at this point. You have R, radii of 1.
Uh-huh.
And they meet at this point. Which again relates to the tangent thing if you were to draw
Yeah, don't draw it all the way through. Just
a tangent line like that.
okay. What would happen there?
There'd be two right angles,
Okay.
and therefore this line is straight.
All right. Nice. Okay.
And then we have this length, which we don't know. We'll just call that X. We don't know anything about this length except that it goes. And this is the center of the big circle.
Okay.
To the point of intersection between these two.
All right.
We don't know what that length is or anything.
Okay. So for now we have two triangles, two right triangles, and two unknowns.
All right.
Okay. How do you think? I know you know how to proceed from here. How do you think we're going to proceed from here?
Well, maybe, let's see, could use the Pythagorean theorem with this right triangle here.
Okay.
So then you can use it to find this length R.
All right. Okay. So do you think we're going to use the Pythagorean theorem? Okay, let's do that.
Alright.
Unfortunately, I'm going to have to erase the picture.